Have you ever stopped to think about the humble wire? It's everywhere. It's in our walls, it's in our cars, it's in our gadgets. But how do you know what size wire you're holding? You can't just eyeball it. That would be a recipe for disaster. This is where the standard wire gauge, SWG, comes in. It's a system, a language really. It lets makers, engineers, builders speak one precise thickness language. Simple idea, massive impact. So what does SWG mean? Standard wire gauge. A British system to bring order to wire manufacturing. Before SWG, every company measured wire differently. Imagine building an early telegraph with mismatched wire. SWG created a set of numbers, 7/0, the thickest down to 50, the thinnest. Each number maps to a specific diameter. Simple solution to a messy problem. It's a bit counterintuitive. Smaller SWG number equals sign thicker wire. Bigger number equals sign thinner wire. The number shows how many times wire was pulled through a die. 10 SWG equals sign fewer pulls than 30 SWG, so it's thicker. A 10 SWG in Manchester equals sign 10 SWG in London. That consistency was a game changer. SWG wasn't just for wire. It measured sheet metal, it measured hypodermic needles, a universal language for thickness, an unsung engineering hero. It made precision and consistency possible at scale. Without it, the Industrial Revolution and tech progress would have been much slower. A simple standard that changed everything. Let's rewind the clock to the 19th century. The world was buzzing with new inventions and industrial energy. Factories were churning out goods. One of the most important components was metal wire. It was used for making nails. It was used for making screws. It was used for stringing fences. It was used for creating musical instruments. But there was a huge problem. There was no single agreed-upon way to measure the thickness of this wire. Each manufacturer had their own gauge system. Birmingham wire gauge, Stubbs iron wire gauge. It was pure, unadulterated chaos, a builder's nightmare where nothing was interchangeable. This lack of standardization was a massive roadblock to progress. If you were an inventor trying to build a new electrical device, you needed wire with specific properties. The thickness of the wire determines its electrical resistance. In plain terms, how much it pushes back against the flow of electricity. If your wire arrived with the wrong thickness, your entire project could fail. You couldn't just swap it out. Another company's same size might be totally different. That inconsistency made mass-produced, reliable tech incredibly difficult. It was like building a Lego castle with bricks from 10 incompatible sets. This is where the British Board of Trade stepped in. In 1884, they legalized the British standard wire gauge as the national standard. It was a monumental moment. They compared existing systems and took the best parts. Then they created one definitive, legally binding chart. Suddenly, everyone was on the same page. An engineer could design a machine specifying a 16 SWG copper wire and trust that any supplier would deliver that exact diameter. Standardization gave industry a common language. It unleashed a new wave of innovation and reliability. The importance cannot be overstated. The SWG system lubricated the gears of the Industrial Revolution. It enabled complex machinery with interchangeable parts. It made electrical systems safer and more efficient. Engineers could accurately calculate loads and pick the correct wire. This wasn't just about neatness. It was about making things work, making them safe, making them scalable. The SWG wasn't just a chart of numbers. It became a foundational pillar of modern engineering, a quiet revolution in precision. With a reliable standard in place, inventors and engineers could really get to work. The late 19th and early 20th centuries were a golden age of technological marvels, and SWG wire was the silent partner in almost all of them. Consider the telegraph, the world's first real-time communication network. It worked by sending electrical pulses down long stretches of wire. The thickness of that wire was critical. Too thin, and the signal would fade over long distances. Too thick, and it would be too heavy and expensive to string across entire countries. SWG allowed engineers to specify the perfect gauge to balance performance and cost, connecting the world one precisely measured wire at a time. Then came the telephone and the electric light bulb, two inventions that completely reshaped society. Inside every early telephone were coils of incredibly fine insulated copper wire, often measured in the higher SWG numbers like 30 or 40. The number of turns and the thickness of this wire had to be exact to create the electromagnets that made the device work. Similarly, Thomas Edison's experiments with the light bulb involved testing filaments of various materials and, crucially, various thicknesses. Having a standard like SWG meant that once he found the perfect dimension, he could replicate it perfectly for mass production, bringing light to the world. The impact of SWG went far beyond communication and lighting. It was fundamental to the rise of electric power itself. The first power grids that snaked their way through cities and into homes relied on massive amounts of copper wire. The thickest wires, measured with low SWG numbers like 0 or 2/0, were used for the main transmission lines that carried huge amounts of current. Thinner wires were then used to branch off into individual buildings and homes. Engineers used the SWG specifications to ensure the system was safe, preventing wires from overheating and causing fires. It was the blueprint for electrifying our civilization. Even in everyday life, SWG was making its mark. The strings on a piano or a guitar are a perfect example. The specific gauge of each string is what determines its pitch and tone. Musicians and instrument makers relied on the SWG standard to create instruments with consistent, beautiful sound. From the robust wires in a suspension bridge to the delicate filaments in a radio tube, SWG provided the precision needed to turn ambitious ideas into functional, everyday reality. It was the hidden grammar behind the language of invention, ensuring every component spoke its part perfectly. You might think that with all our modern technology, a 19th century system like SWG would be obsolete. But you'd be wrong. While other standards like the American wire gauge are more common in North America, the SWG is still widely used across the United Kingdom and in many other parts of the world, especially in manufacturing and engineering. It remains a crucial standard for specifying the thickness of sheet metal, which is used to build everything from car bodies to the cases of our electronic devices. The legacy of that simple, powerful idea of standardization lives on. In the world of hobbyists and makers, my kind of people, SWG is still very much alive and kicking. If you're into building models, crafting jewelry, or winding your own electric motors or pickups for a guitar, you'll constantly encounter SWG sizes. It's the language used to buy the right materials for your project. When you need a specific wire for a delicate electronics project or a sturdier piece for a mechanical build, the SWG number tells you exactly what you're getting. It's a direct link to the pioneers of the past, using the same language of making that they did over a century ago. Of course, the way we make wire has changed dramatically. Modern manufacturing processes are incredibly advanced, capable of producing wire with breathtaking precision and consistency, far beyond what was possible in the 1880s. We have new materials like fiber optics that transmit data with light instead of electricity. Yet the fundamental need for a standard to define physical dimensions hasn't gone away. The principles established by SWG, the need for a universal, reliable system of measurement, are more important than ever in our interconnected, high-tech world of global supply chains and microscopic components. So, the next time you plug in your phone, turn on a light, or even just see a construction site, take a moment to think about the wire. That simple strand of metal is part of a grand story, a story of innovation made possible by a brilliant and simple idea, the standard wire gauge. It's a system that brought order to chaos, powered a revolution, and continues to be an essential, if often invisible, part of our daily lives. It's a beautiful example of how getting the small details right, of creating a standard, allows us to build incredible, world-changing things. And that is awesome.